Hello, everyone, and welcome to Chapter 2 of Introducing Python. So to remind, we're going to get started on this, but to remind how to get in there, we're first going to want to open up and launch JupyterLab. So I'll go do that here now in my terminal by typing JupyterLab. That, of course, runs a little server, and it pops up in the browser. So here we have the browser window, and I'm just going to get out of the way here. So to remind that the chapter notebooks are available through the GitHub archive, github.com/BernieHogan/introducing Python, and you can either run them on your local computer through JupyterLab, as I've just done, or by selecting one of these buttons here and launching either Binder or Google Colab. So as I normally recommend to do, once we get into the workbook itself, is to first restart the kernel and clear all the outputs. Now I do often keep the outputs in the versions that you download from GitHub, so you can compare your results to what was originally there. But also it's a little bit underwhelming to have the the answers or the outputs underneath, and you'll want to check to make sure that it runs correctly for yourself. So here we have. It says two basic types of data in Python: primitive data types and object data types. So primitives are the real basic blocks of all the other stuff. There's 5, as I understand it, primitive data types in Python. First we have int for integer, float for floating point numbers, char for characters, byte for a kind of string interpreted by the computer, for example, storing image data, where it just comes in as a stream of stuff, and then bool, or for boolean, namely true or false values. So you can really only have a true or false value there. So from these, we put together a whole lot of other different types of data, but they are the basic building blocks right here. So now normally you don't want to type out some primitive data yourself. You want to represent that data by some abstraction, and then work with that abstraction as maybe the data changes. So in this case down here, we'll see I've got one of these such abstractions, which we call a variable. I run this, and it says new string is not defined. So it's like, what's going on? But now look what we'll do here. We'll first define that new string. We'll say hello world, and then we'll print that. So there we go. So you notice variable names in Python, they start with an alphabetical character, and when they can include numbers and underscores afterwards. So you'll often see a convention that I use, which is some sort of descriptive, followed by an underscore and the type of the variable. The type of the variable isn't necessarily obvious from the variable name, so that way it helps me kind of track my code. So up here we had this new string, and now just look down here, we're going to add another word to it. It says hello world, and we add hello. And so imagine, what do you think it's going to look like when we do that? Okay, so we can see here it didn't add any spaces or anything. It just literally appended hello, H-E-L-L-O, right after that exclamation point there. And so it's now we have hello world, hello. You'll also notice that we started this string right here with these single tick characters or single quotes, and we started this down here with these double quotes. Now you have to start and end with the same kind of quotes, but you can use different kinds of quotes. We'll see a little more about that now down here. So here's the first quote, just as so forth. Here's the second one, a double quote. Now to notice that that's different from the stylized quotes that you might see perhaps when writing in a word processor, and it'll autocorrect these to some nicer quotes that are like curled towards each of the text. But we're referring to these generic quotes. Now, sometimes it might be okay with those others, but you wouldn't really want to trust it. You really want to make sure you have these double ones here. Now, if you're writing in a code cell, Python is not going to change these characters into the more stylized ones. It's just going to keep as is. So you just have to press your quote character on your keyboard, and it should work fine. But now what happens here, you notice here we've got no quotes inside of it, but here we have the word doesn't mind. Now that's a single quote, so we can put it in these double quotes. But what if we want to put double quotes inside double quotes? So if you wrote, we all live in a society, man, with some sort of scare quotes or something in it there, then you'd have to find a way to use these double quotes within this double quoted string statement. So in that case, we use what's called escape codes. So these escape codes here, this slash quote here, will now escape this one, so it's not seen as the ending quote. And you'll see some other escapes now in a second. We'll have a really important one is slash n, and that's for new line. Now, if you want to put a new line in a sentence and you don't escape it, say with using the slash n, you can, in fact, do that in Python by having the string break across the lines. But you can only do that with this here, with these 3 ticks. So you put 3 ticks in a row, and then it's just going to continue assuming that everything else it sees is string, is text, until it gets to another 3 ticks. So let's have a look down here at how these work. Well, here we have first one small tick for strings, and then the Python doesn't mind the tick here, and then have a look at these right here, all of these. Now, let's test this. Let's see, it says I have no problems breaking across the line, so what if we break across the line over here? Well, first of all, we got a clue that it's not going to work out very well because we can see that the syntax highlighting has shown that this is in black. But now certainly if we press, it says unterminated string literal. Unterminated, which means it didn't stop. And string literal is referring to this text right here. Let's have another look here at one of these errors. So you look at this, it says if you'll get a syntax error, and then it'll point to this, it has this caret that points to here's where it's getting the error. Now, in fact, the error that's happened actually happened over here because this wasn't escaped. But in this case, it's trying to give what it thinks is its best guess of why it went wrong. In this case, it's not an accurate guess. Maybe it thought that we wanted to do this and think of society as like a variable that we would also print in here. But who knows? The point is that the debugger tried to give some output, but it wasn't necessarily great at doing that. So here's some pointers for how to sort of manage that. The first part, the bottom part is closest to your code, so you might get some errors where you have lots of traces of things going up through the code. And it might seem quite intimidating if there's a long list of them, but really you want to scroll right down to the bottom of that error, and that's where the most immediately precipitating thing happened, and that's the bit at the bottom will be the code that you'd have to attend to. Second thing is try to print out at many points to get feedback. So in this case, we could print that out. We could do something like put a parenthesis after here. You can print that out, or if you'll notice what I'm going to do here now, if I use a hash mark, that's going to comment out this text over here. So you'll see it's in light blue, and that we can now print this out, but it doesn't really get what we wanted to happen. As you go on, you'll see other approaches where it's really important for us to print things. You might also want to break the problem down. Try to make little tiny small changes and see how it affects the code in order to get to where you need to. And of course, there's things like examine online forums that have received a similar error. But be mindful of what you throw into a search engine. If you put this into a search engine, why doesn't this work? It might not know that these words are relevant. You may want to consider entering it into a large LLM, such as ChatGPT, and asking it, because I do think that it would almost certainly, GPT Turbo, or the cheap and free one, would almost certainly be able to get this error based on this, and perhaps give you a helpful or useful explanation. So now here's, of course, how we use those escape quotes, and we can see there that now that this has happened, it's fine. So you can see how to escape the single tick. Let's say you're putting these single ticks here, and then you have contractions in there. And that's how to escape the double quote. And then what about to escape the backslash itself? And so you can actually use the backslash to escape itself. Now, as we might have suggested above, not all characters are visible. We need to find a way to print, say, a new line statement. And there's also ways to print tab statements. So that's when it kind of goes in, maybe about 4 spaces in. So we'll see here. This is me creating something not unlike a haiku. And you'll notice the spaces that we have here. This is A New Line by Bernie Hogan. Autumn students learn a tab that provides structure may not provide space. So I'll leave that with you to think if there's any deeper meaning than that. But what I really want you to pay attention to in this Python code is the fact that we're using these tabs here. That's going to push this forward by kind of a consistent amount, and that these new line characters help break up the text. But you'll also see that we have escaped the new line, so it might seem a bit tricky in here. We escaped a quote, we escaped a new line, and escaped another quote, and that's how we were able to. Reproduce this right here from the text itself. Try deleting little bits of this, seeing how it affects it, and so then maybe it can guide you into ways you can help with the formatting, or inspire you for your own haiku. So moving on to the next section, this is where we talk about numbers. Of course, we're not just interested in text in computation, but often in numbers. So the two basic kinds of distinctions between numbers is whether it's a whole number or whether it's something that can be divisible, for which we describe as an integer or a floating point number. So integers don't have a decimal. They won't say like 7.0. They'll just say 7, whereas a floating point number right here, for example, 4, will have a decimal after it. Now you don't need to make a number a floating point. If you are doing some sort of calculation, such as if you said 7 divided by 2, it will know to make that 3.5. But on the other hand, you can set a number to be a floating point number by saying 0.0 at the end of it. Look down here, we see I've used a new function. So of course, above we've used print a lot, and now we're going to use a different one called type. And in fact, I'm going to nest type within the print function. First, we're going to print the type of x and then the type of y. It should be an integer, and it should be a float. And then you'll notice what happens when I create a new variable called z, and it inherits the floating point number. Even though the value could have been an integer, we can see here it's going to be 11, 7 plus 4. So that 11 is, it doesn't have anything after the decimal point, so maybe it should be an integer. But what happens is that whenever an integer gets in contact with a float, it always upconverts to the float to make sure it has the best precision possible. So you see here printed the type of x, the type of y, and then the type of z and the value of z. And it's not 11, it's 11.0. You can change those values from one to the other. So watch as I convert all of these here. Now, what if we want to loop right back around to an integer? So first we're going to have our variables 7. So I print it and its type. Then we make it a float, and so then it should be 7.0. Then we can actually turn it into a string because this is a character, so it's just like putting it in quotes, and it'll be a string character rather than a number value. So you can see how I've described this here, int, float to string. But now what if we want to turn it back into an integer? It's going to be, it's going to have a challenge. It's going to say value error, invalid literal for int, base 10, 7.0. Now you might think that 0 means nothing, but it's not nothing in the sense that it's information that this is a specific kind of variable. So it will caution you ahead of time with this one. So we see so far so good. But now just watch what happens when I do that here. Invalid literal for int with base 10, 7.0. So we couldn't actually, in this case, cast that, but we can work with the numbers anyway. So now what Python is here is an example of a language that we would say is weakly cast. And cast is like a casting, like a mold, like put it together and out comes, I don't know, some sort of figurine or something. In this case, what we do is we cast a variable and we say it's an integer or it's a string. Some languages are strongly cast, which means in order to create a variable, we might have to do something like int var x equals 5. Now, as it turns out, Python doesn't need that. In fact, it gets quite confused by it. You can just say var x equals 5, and it knows that it's an int. But you wouldn't explicitly state that there. Now, there's good to that and there's bad to that. Well, the good thing is that, as you can see up here, we haven't had to declare it everywhere, so it's made the code a little simpler, a little more lightweight. But the problems can happen when we get a little bit confused about what our variable actually represents. So one of the most useful ways to do that, of course, is to remind, be able to print the type of the variable, as well as print the variable itself. And that can also help you get through a lot of debugging. So here are some basic number operations that you can do in Python. They're kind of the common ones, but I do want to highlight a couple here that you might have not seen for a while, such as long division, but they can be really useful. So here we have addition, subtraction, and multiplication, kind of the basics right there. You notice what happens when we have two of these asterisks. We actually do an exponent. So that's like to the power of. And but while that's an exponent, 2 slashes is not the same as like to the inverse power of or to the square root of or something. Two divisor symbols, here's one divisor, it actually means integer division. So we'll see how that works now in a second. But I do want to say that the complement of integer division is modulo. So that's the remainder when we do long division. And we'll see how this works up here. So x equals 9, y equals 4. We've got a couple numbers. And you see how I've printed them there. X plus y equals 13. Minus y equals 5. So far, so good. 36. Now just watch x asterisk asterisk y. So that is 9 to the power of 4. So that's a big number. Getting bigger. Now, x divided by y, 2.25. So there's 4 of those in each 9. But now there's actually 2 here. So if we say y is 4, that means we can fit 2 4s inside of the 9 and no more. But we'll have a remainder. We'll have some space left over. And how much space do we have to over? 1. So this remainder right here is going to be really useful because the remainder, say, will only be 0 every 9th time. So just watch this. Say x modulo y. Now instead I'm going to change these numbers and I'm going to make that one 18 and that one 9. So the modulo should be 0. There we are, because we can totally just divide 18 by 9 and not have any remainder. Now where this comes in handy, as imagine now instead of 9 we'll use 10. And we'll say this is 100 modulo is, and there's no remainder. But what about 101? There's a remainder. There's a remainder. 110, there's no remainder. So what we do is we often use modulo as a counter. So we'd say whenever modulo is 0, that would be the nth, every 10th time, every 100th time, every 1000th time, then maybe do something. If you have a lot of data, say hundreds or thousands of lines of data, you might not want to print every line. You might want to print every nth line. And so you can use modulo there for that purpose. Now, floating point numbers are, in a computer, still finite to some extent. We can, in theory, calculate numbers to a very, very, very long or very large degree, but when we actually instantiate them as numbers rather than just as mathematical symbols or abstractions, we've got to stop the number somewhere. So let's see how that works with our numbers here. And this is kind of an interesting little quirk or trick in Python. So check this out. x1, y1, z1, they're all going to equal a third. So let's watch and see how they don't add up to 1. Okay, so then why is x plus z plus, why is that and not 9999999? Well, that's pretty interesting. Now just watch what happens. 1 digit short right here. Just watch when I run this. Huh. So here we have 999996. So if we have 1 digit short, this adds up all the 9s, and then there's an extra 6. But if we have indeed all these numbers here, it rounds up to 1. It makes an assumption about these numbers. This floating point stuff isn't quite super precise. And now, interestingly, check this one out. Okay, so x3 minus y3. If we take x3 minus y3, so what that would be 16 minus 7, which is 9 over 9. So shouldn't 9 over 9 be 1? No, indeed, it's all these digits here. So in the limit, floating point precision can actually have some kind of funny issues with us. But in most of the level of precision that we'll need in our data, this is really not to be concerned with. But the important thing is to say that it's stored in the computer with a sort of a finitude, a level of precision. Even if it's a big level, it's still finite. So as I mentioned above, a string is a collection of characters. Now, a collection of characters really forms the basis of a lot of work that we do, whether it's storing data in different file types or taking the characters in strings and processing them in some way. That's how we get to learn how to, make things like programs that manage text and analyze it, do sentiment analysis, or even go up to the sort of abstractions that we see like large language models. But it really starts just right at the beginning with how do we take the string, which is itself a collection of characters, and transform it in some way. Now, a string is not just a character, but it's actually what we would call an object. So most of the data types that we see in Python are objects. Now, the thing about objects is that they often have special properties that you can apply to them and things that you can do with them or things that you can get out of them. You might have an object that refers to, a document, and then you can say, get all of the words out of this document, or get page 2, or get all the links from the document. And those sort of things that we do to that object, those are methods. We'd say maybe there's a method for, getting the links from a document. Now, some string methods here, some pretty simple ones, are worth considering, just to get us a feel for how methods can be applied to objects. So look at this. I left var here to stand in for whatever our string variable is. So it could either be this, or maybe we say x equals this, and then it's x. So if we go upper, it will return a version of the string all in uppercase, and lower will return it all in lowercase. We can do a bunch of other things here, like we can find things at substrings, return some value if it's alphabetic. So if we put in there, if we put the string is 1, 2, 3, 4, 5, and they'll say is alpha, it'll return false. Now, when I say 1, 2, 3, 4, 5, I don't mean an integer value. I mean if you put in quotes 1, 2, 3, 4, 5, or perhaps put in quotes a period or an at symbol, those won't be alpha characters or alphabetical, so it'll return false. We can replace something with something else in a string. So within this string, if it has a bunch of words like say it says banana, and then you replace the A with an I, then you got bananas. You can take the white space off of either side of a string, and that's often really useful because when you parse or split up strings, you might have like a new line character at the end, or maybe a tab character, and really what you want is just the word. So that's referred to as stripping it of the white space. So you can just strip the white space out of it, or you can just strip from the left side or the right side, and that's with .lstrip or .rstrip. If you want to find out details about a method, you can check the help, and there's lots of ways to do that in Jupyter. I mean, the first way is to do this. We can just run. So if I'm wondering about this string.find, so I've got a little string variable here. I say string.find, and it'll give me the help. Now you'll notice that what I have here, string.find, and then I have this parenthesis afterwards and stuff in it. That right there is an argument that we would send to it. So like with the print statement, we send some strings and then it prints the string. But now notice what happens if we put the parenthesis in here. Then it says find takes at least one argument. Okay, so sure, let's say we put t. And it'll say help on int object. Now why is it saying help on int object? What do we mean by that? Well, just notice what happens here. If I have str right there, that's a type, and it's a string. Sure, but now look what happens when I do find. Find is going to return the number where it finds t. So it finds it in the 1th position. Now, what do I mean by the 1th position? Well, I don't want to say the first position because numbers or collections in Python are indexed starting from 0. So this right here is entry number 0. That's entry number 1, and then entry number 2. So it found that, and you can see here if we put R, it'll be in, position 2. So what happens is that this has returned a value, the number 2, and then it's doing help on whatever this value was returned. Now, if we wanted help on just the find statement, or the find method, then it actually returns the method. Now, actually, watch what happens here. If I See, it just returns this method itself. So that's the first way we can look at help for any method. And but there's a few others that you can see along the way. One is to press Shift and then the Tab key. Watch that. And so since we're inside the this help function right here, you can see we get this help for the help function. So let's see how we might use one of these string objects, or one of these methods that we can apply to a string object. And yeah, let's check it out down below first. The quick brown fox jumps over the lazy dog. Pretty classic quote. One of the shorter sentences that you can make with all the letters of the alphabet. I think there are shorter ones now. You can look them up. But we'll stick with this one. So here's the original string. And now just look what happens with the methods that I put there. For upper, quick brown fox. For lower, the quick brown fox. And then, is it just alphanumeric? False. Why is it false? Because it has these spaces in there. And now just look what happens when we replace O with U. So we get this weird sort of way of seeing this, the quick Brion fox and so forth. But you can get a sense of now how the replace statement works. And back to that thing about Shift Tab. Down here, see example string.replace, and then it gives a little bit of an explanation here, old and new. And then there's a count. So what does count mean? The maximum number of replace all occurrences. Oh, so for example, we can now use that count, perhaps and say 1, so it'll only replace the first one. And you see the rest of them, they remain where they are. And we can replace 2 of them, and so forth and so forth. So as it happens, a string is really a special kind of a list, and it's a list of contiguous characters. So we can use a lot of properties of list. Now you can jump ahead to the next chapter to see more on lists, but I think this is a good entry point into it to start here. So here we have the string, which is the string itself. And now just watch what happens when I do this thing right here. It's called split. And then notice what happens when I cast it as a list. So string.split by default splits by a space. And so sep says num, when it's set to none, then it will split on any white space character. So what happened is it split it here into a list of 5 elements. Element 1, element 2, or element 0, 1, 2, 3, and 4. It takes a bit of time to get used to that. Now you'll notice though when I recast it as a list, I said a string is really a list of characters. Well, it is and it isn't, because when we make it a list of characters, look, we get these, it's like each element is separate. And its own element in this list, whereas what we really want to use is just something like this. Now you notice when I said split, we said split on the by default, it's the white space characters. So these methods have a notion of a default parameter, and that would mean there's actually, for a lot of methods, there's like a lot of defaults that are set, and you don't need to toy around with them, but you can, under various circumstances, make use of them. So now if we go down here, we'll see split, and then we have ing here. So singing, dancing, grooving, and let's see, we have the string itself, we split at every ing value. But now you'll notice here we split only the first instance. So now you might be wondering to yourself right here, why is there an S and this sort of like 2 empty characters here? Well, look what happens. The word singing has ing in there twice. So the first time it splits on this one, and we just have an S. The second time it splits in between these two, right there. And when it does that, it just says it's empty, but it's still, there's an ing, and there's an ing in between all of them there. The reason we have this empty one at the end is because we have an ing at the end. So it still says this. Otherwise, we'd say this returned groove was the end of the string, but in fact, in this case, there was something else. There was an ing at the end to begin with. And we can check that here. Just watch this. And so now there's no second space, but we still have this here. And if and like so forth. And now we just have 3 elements instead of the 5 that we had before. And so here we have the replace statement, and it works in a pretty similar way to the split statement above here. But instead of splitting in these lists, it just takes those ings and it turns them into something else. So down here we're replacing ing with some asterisks here. Maybe the fun police have probably shown up, and so forth. There we here's what we originally had: singing, dancing, grooving, and here's what we're left with if we replace them. And here, if we only replace the first one, then you can see it looks like this. So a really common task with strings, unsurprisingly, is to combine them together. There's all sorts of purposes for doing this, but many times you would want to combine strings, not just actual like quotes of characters, but variables, so that you might have a form, and then you can fill in the name for a whole list of names, or other sort of ways where you can report on things with variables. So we'll show how to combine some strings here now below with two main strategies. The first one is concatenation, and the second one is insertion. So concatenation, as you can see, has got the plus symbol here. So the plus symbol then is overloaded. And what that means is that they have different purposes depending on their context. So now just watch here. We have blue and berry. We're going to use the plus symbol there. And then we have 7 and 9. And then you notice we have 7 and 9 as strings. So in the first case, blueberry kind of came together. And then we got the number 16. But down here we have the number 79 because they're treated as strings, and so they're put together as strings. And so here's just, example of the filling the form, hello, and then a name. Now, while that's concatenation, we can also insert them, and inserting them is really handy. So now have a look at this down here. It says your score was blank out of 30, or score divided by 30%. So let's just watch this. And it says you can only concatenate stir, not int, to stir. Okay, so this is going to be a problem for us if we actually want to use some sort of data and some sort of report. So there's a couple different strategies that we can use for that. One is we can take this number and then cast it as a string that we saw earlier. But that might be a bit tedious every time, and we might want a more compact way to do that. And so we can use the format command here. And there's two different ways to use format. One way is to append .format to the end of the string. So you see we've got these parentheses in the string. When you append .format to it, it looks for those parentheses, or rather braces. It looks for those braces, and so it has two things here, and we have two things here, so it inserts them in there. The other way to do that is to kind of embed those two. There's some syntax in Python, and I use this all the time, called F insertions. And so instead of just starting with a quote, letting the computer figure out it's a string, you start with an F and then the quote. And so then it says, this is an F insertion. Pay attention to the braces. And you'll see now in the braces we've put score inside of them, and then this sentence here should print pretty much the same as this one up here. Okay, and so you can see that it worked out pretty well. In both cases, we've got our score in there, and then we've got some percentage afterwards. But it's not really a percentage, is it? It looks pretty garish. It's like 5, and it goes really long all the way to the end of the floating point numbers and rounds up. So you'll see later ways in which we can format this so that we can make this number a little cleaner, a little tidier. But for now, I think it's just worth remembering that we can take numbers and place them inside of strings using these F insertions or this format. So now down here, you can see what we've done is here's our score divided by 30, and then we've got a colon here, and then some other stuff at the end. So just watch this. Now this is going to hopefully be formatted for us a little more nicely. As you can see here, now we've got a decimal point and then 2 digits. And we've got 2 digits because this right here is actually give me the digits, and after the period, give me 2 significant digits. And so if we put 3 there instead, like so forth, and you can get the picture going back as far as our digits go. But this way we can make our numbers a little more clearly when we print them and go to the appropriate level of precision. You don't really want to print numbers that are really, really, really long if the length of it is so long that you can't really compare the difference between two numbers, and you're just seeing numbers at what we might consider an artificial level of precision relative to maybe what you sample on. So instead, just keeping the numbers nice and tidy, say by making 2 or 3 significant digits, can really help with your presentation of data. Now just watch what I've done down here. This was like 0.57. Remember, we wanted to divide 17 by 30. And we got 0.57, but that's not a percentage, is it? So just watch what happens here when we use the percent symbol. Well, first of all, the percent symbol turns this into a percentage. So instead of being 0.57, it's actually 56.67%. And now this time, you'll notice the 2 didn't refer to the percentage. It wasn't these significant digits. It was still these significant digits right here. So just watch that. And now this is how you can take a number and then format it nicely within a string and then report it in some meaningful way. So that really takes us to the end of this section here, just on primitive data types and strings and floats. And you'll also see that as we got to the end of it, it got pretty hard to explain new concepts without getting into the next section, which is collections. As we've seen above, these strings are really in ways kind of like lists because they have lots of elements in them and we can index them. But you'll also see these right here, with these braces, they look like a thing that we'll see in the next chapter called a dictionary. And perhaps I'll see you over there for that. But that concludes this chapter. Thank you for watching.